Now, Minitab is a computer software package that allows us to do some program to do find some values from data sets. We do not have that package, and we will not use it, but we have to know how to use its printouts. Now, here is a typical uh, printout. This one is a thing about Leonardo da Vinci. Speculated that the ideal human would have an arm span equal to the height. And here's some regression of height and arm span. And if you typed in the data into Minitab, this is what it would kick out for its regression analysis. We need to figure out what this means. The dependent variable, height, that's our response variable. So that's your y value. Your uh, independent variable, your x value, is down here, your arm span. So your arm span is here, your response is the height. So we know we're doing arm span and height. Now, there's a bunch of other data in here. The, the number just to the right of this gives us the slope. And if we go just to the right of that, that gives us standard error for that slope. And then we'll learn about these t ratios and probabilities later on, but right now we don't have to be concerned with them. On the top, our constant value is our y-intercept. So this is another way of just saying y-intercept. And this is the value that our y-intercept takes. And we don't do much about standard error of y-intercepts or t or probability in this class at all. So we don't need that. So all we need to know is our y-intercept is that value. There's some other data here. This S refers to the standard deviation of residuals. R squared is just where it says R squared, 87.1 or 0.871. And now if I wanted to find R, I would have to take the square root of this and then look at my slope to see if it was positive or negative. R squared adjusted we don't deal with in this class, and degree of freedom, this is something we'll learn later in the year. Um, this analysis here we don't do much with. The sum of the squares of the residuals, this is, remember when we did sum of squares, we wanted that to be the lowest, and when that's the lowest, we have the best line. But that's all the data in a nutshell. So if it says find the slope of the linear regression, our slope is 0.84, and interpreting it for each increase in uh, 1 unit of arm span, the height increases 0.84 units. All right. Now, from that, we can find the y-intercept, interpret that, write the least squares regression line, and then we can find the height of a person who's that many inches, and do fill in the standard deviations and interpret them. Now, this is a very important topic, and this is asked often on an AP exam. So I want you guys, since we've already done all of this, I want you to take a minute and try to interpret all those values and see how well you do at it. Good luck.